the flexibility and the resilience that we as teachers have shown over the past few weeks has really been amazing, inspiring even. Give me a moment. I'm going to switch over to my slides.
Ah.
So we're going to talk today about how to help develop a mindset for reasoning and problem solving. Before we begin, I'd like to start by noting, as I often do with presentations, my goal for us this afternoon and beyond, and that is to step outside of our comfort zone. And I mean that in a good way, because I really think that's where we're trying new things, and more importantly, we're learning new things. And stepping outside of your comfort zone is going to look different for everybody. For some of you, the things we'll talk about today might be new ideas, things you haven't thought about before. And so stepping outside of your comfort zone might mean thinking about these things and what they mean for you and your students. They might mean trying some of these ideas out with your students. For others, stepping outside of your comfort zone might mean that you're familiar with these ideas already. So you might encourage a colleague to try some of these things out, or you might take these ideas and go even further with them, refine them, further develop them for use in the classroom or with your students. Whatever stepping outside of your comfort zone looks like for you, your learning is ultimately going to be benefiting your students. And that's what I think is most important. So let's talk about struggle. What words come to mind when you hear the word struggle? I'll give you a moment to think about what pops in your head when you hear the word struggle, and please share some of those words in the chat. And don't feel, please don't feel hold back if some of the words have already been used that you're thinking of. I think that just adds to the importance of those words. Yeah, I see frustration, I see stress, challenge. Ooh, disequilibrium, that's a good one. I haven't thought about that. Failure, quitting, challenge again. Yeah. Learning. Embarrassment. Lots of great words. Anxiety. Pain. I see pain. Yeah, so here's the next question. Not necessarily for you to respond to in the chat, but definitely something to think about. How many of the words that you saw in the chat were positive?
Very few.
So here's what we know about struggle. Struggle, often thought about negatively, thought of as a bad thing, and often as evidence of failure, right? We think about struggle and not going well. We think about struggle and the opposite of succeeding. If we were doing well, if we were succeeding, struggle would not be something that we'd be feeling. And in terms of teaching, when we think about struggle, we think about ineffectiveness, right? If our students were struggling, that means that our explanations were ineffective, or our teaching was ineffective. Because if we were effective, if we were doing what we were hopefully doing, then our students would know what to do and how to do it. They wouldn't be struggling. So it kind of goes against the idea that struggle is a good thing in terms of teaching. But here's what we also know about struggle based on science and based on research. First, struggle is possibly one of the best times for brain growth and for learning. And this is central to what Joe Bowler talks about in terms of a math mindset and what Carol Dweck talks about in terms of a growth mindset. The idea that struggle is inevitable, and that most important is that you think about struggle as an opportunity, and through hard work and through effort and through seeking out help when needed, you'll find opportunities to persevere through that struggle. And that can only be a great opportunity for learning. And Joe Bowler would add on that in your brain, when you're struggling, that's when you're working your brain out, much like you would work out a muscle. And as you're struggling, you're making new neuron connections, which is evidence of learning. We also know that it's inevitable in math, struggle for sure. Anyone who's done enough math knows that well, it's only a matter of time before you're going to make a mistake or you're going to struggle. And we also know that along with that struggle in math comes a much deeper and richer understanding. If you are thinking about a math topic and you're looking at it from different angles, if you're taking it and you're turning it upside down and interrogating it, all of that work is really leading to a much richer understanding of the math topic, of the math that you're thinking about. And that leads to lots of great benefits. One of them is that those experiences, that struggle, what you've learned, what you take away from those moments, you're able to apply in new situations, in new environments, in ways that you may not be able to had you not had that opportunity to struggle, had you not had those experiences. So it's really powerful for transfer, um, different contexts, different problems, different math topics. Unfortunately, though, we also know that in the US, our students are not given many opportunities to struggle. In fact, what we do is we try to avoid struggle by giving our students nice tricks, things, rules that they can follow. So they don't really understand what they're doing or why they're doing it, but they know that if they follow this acronym, they'll be able to arrive at an answer that is going to get them what they need: grade, approval, whatever it is. FOIL, right? I'm sure many of you have heard that one. Or please excuse my dear Aunt Sally, PEMDAS. Take a look at the one on the right here, cubes, right? Those are, you follow the cube, you'll be able to problem solve. So we've spelled out procedurally exactly what students should do in problem solving. I'd argue that that's not problem solving at all. But it's helpful sometimes, right? We think that if our students are struggling, that's not a good thing, and we want to help them avoid that struggle. We also know that there's not a lot of resources out there, even if we wanted to engage our students in struggle. Sometimes one of the obstacles is finding those opportunities, those tasks that are going to allow our students to engage in something struggle worthy. The two pie charts you see down on the right come from an interesting presentation I was at maybe a year and a half ago, where some teachers looked at the top 100 lessons from teacher paid teachers in Pinterest. And one of the things at different grade levels, they took all these lessons and analyzed the types of problems that were a part of the lesson. And you see that small slice in green, the 0.7% and the 0.8%, those are the percentage of tasks, of lessons that involve real problem solving that's struggle worthy. So not a lot of opportunities, even if you wanted to go out there and find these resources, they're not easy to find. And the same is true with the title on the left, just an example of even the curriculum, the textbooks that we get don't involve a lot of rigor, don't involve a lot of challenging tasks that struggle is inherent in. And what do we do as teachers, even if we do happen to stumble upon some of these problem solving tasks that are really going to encourage struggle, we rescue, right? We see that frustration, we see the angst in our students. Maybe a hand goes up. And we go over there, and as teachers, we begin to ask very pointed questions that will lead the students to the answer. And in doing so, not only do we remove the struggle, remove the opportunity for struggle, but students don't really know what the point of those questions were, why we ask those questions, and so they don't take away a learning experience; they take away an answer. And that's it. That's the result. This happens so much it even goes by a name. Actually, has two. It's called the universal helping interaction, sometimes also referred to as a didactic contract. And many have shown that this leads to what's called learned helplessness in our students. And so all these things are also evident in the data, in achievement data. Here we see, this is from NAEP. So if you're not familiar with NAEP, NAEP is a regular assessment that's given nationwide to students in various grade levels in various content areas. In this case, we're looking at math. And so what you see here are the numbers, the percentages of students across the country who are proficient or better in problem solving. What stands out to me in this one in particular, take a look at 12th grade. 25% of 12th graders recently were proficient or advanced in problem solving. Gets a little bit better in 8th grade, even more better in 4th grade, but far from a majority of our students, even in 4th grade. And if you begin to unpack this data, one of the things you'll see is that these averages are not consistent across the board. Are Native American or American Indian students lower than average? Are Black African American students lower than average? Look at that, 7% in 12th grade. Hispanic students lower than the average. Our English language learners, 5%. Look at 8th grade and 12th grade, 5%. Here we have students with low SES backgrounds, often identified by their enrollment in free and reduced price lunch, and also students who have been identified as having a learning disability. So a question not for the chat, but something to think about, perhaps rhetorically, is the question here. What would these numbers look like if things were equitable? And another question, what would teaching and learning look like if we were doing better? Now that second one, that's a loaded question and a very complicated answer, to be sure. There are no silver bullets here. But that's part of the answer is going to involve struggle. And that's giving all of our students opportunities to struggle. Not just certain populations, not just those we deem are ready, not just those we think have advanced math skills. This is all of our students, the opportunities to struggle for all the reasons I mentioned earlier, because of all the benefits, all the value that we find in struggle. So, how do we support our students in struggle when they're learning math? Well, I'd like to propose today two ingredients, shall we say, in this recipe for trying to help our students as they struggle along, and not rescue them from the struggle, but grow and learn as part of struggling. So the first, we need to create an environment, one that encourages struggle, one that allows students to make mistakes and feel comfortable in that struggle, and know that it's good for them. And then once we have that environment in place, we got to give our students opportunities to struggle, and we got to support them along the way, not rescue them. So let's talk about the first one first. How do we create that environment? Well, first thing that's really important to do is we need to make sure that we share research about struggle. We let our students know the value of struggle, how it's connected to learning, why it's important, and how perseverance is all tied into this. And this quote from Joe Bowler, I think, really just sort of says why. To give it voice, she says, well, in a number of studies, people's mindsets have changed when they have been shown the evidence of struggle and brain growth. Once people become aware of the science, growth and change starts to take place. I see it in students and hear about it from teachers all around the globe. The science also supports this. And this is really easy to do. If you just do a quick Google search, you will find that there are lots of articles, lots of research written for a general audience that you can share with your students, that you can read and summarize for your students, give your students opportunities to learn about the importance of struggle, about how it's tied to learning, about why it's necessary as part of learning. And for those of you who are looking for more of a one-stop shop, a great place for that is the website UCubed, which, if you're not familiar with, this is a website that Joe Bowler is a part of. And if you go to this website, there's lots of different things. I definitely would encourage you to go and check it out and explore. But for the sake of what we're talking about right now, if you were to click on the Ideas and Impact link, one of the things you'll find is a variety of different articles, research, things that you can share with your students about struggle, perseverance, and learning. And if you were to click on the films link, one of the things you'll see is a variety of different videos made for or made by and for students. Some a little cheesy, I'll confess, but nevertheless, I think a very effective way of communicating to students what struggle is, why it's important for learning, why perseverance and struggle are all connected with learning, an important part of the process. But that's not enough. It's important to share the importance of it, but we can't just stop there. Another thing we need to do is establish norms for struggle. What does struggle look like? What does struggle sound like? What does struggle feel like? And also, what doesn't it look, sound, and feel like? These are things that are not necessarily obvious to our students, especially if they're thinking about struggle in a negative way, something that they want to avoid. It's not something that they want to spend a lot of time thinking about. So it's establishing norms, meaning helping our students understand that this is a normal part of the process, and these are the ways that it looks like and sounds like. And if you are experiencing these things, if you are doing these things, great. This is, from what we talked about a moment ago, an important part of learning. So make sure that with students, not just telling students, but with students, help them see, maybe it's the pit, as you see here, how learning involves a lot of different layers. Some of it involves frustration, struggle, and that's okay. Important along with that is to help students understand when you are struggling, when you are stuck, what should you do? What sort of resources are available to you? Not just the teacher. What sort of things can students use, can independently use to try and work through, to persevere through the struggle? And lots of different problem solving strategies too, right? Like on the left here, some ideas about what you can do when you're stuck. You can guess and check. You can work backwards. You can solve a simpler problem. Maybe start by drawing a picture, um, or whatever it is that you can do to try to come up with a way to persevere through your struggle. You'd be surprised how just giving students ideas about what's available to them, how valuable, or how the value that students see in just having that, having a list, something they know they can reference when they are stuck. And then it's important to value struggle. Again, we can talk the talk, but if we're not walking that walk, then all the talk that we're doing is not going to really amount to much. And we don't want to just pay our students lip service. We want to make sure that we value struggle. What do I mean by that? Well, to kind of help paint the picture, I'd like all of you to read this vignette here. This comes from NCTM's Principles to Actions book. And as you're reading, a couple things I'd like you to think about. One is, how are the experiences between these two teachers different? And what seems to be valued between these two classrooms? So I'm going to mute myself. I'll be quiet. There's nothing wrong with the audio. I just want to give you some quiet time to read through this vignette. Just want to let you know I'm still here. A few more, maybe 30 more seconds, then we'll move on. And it's okay if you don't get through this. This is all recorded, and I would invite you to come back and finish reading this later. All right. So, how are these different? Well, I'm not sure how to pronounce this, so we'll just say Miss F. One of the things that Miss F does is as soon as she recognizes the struggle, she takes over the work. She rescues them, if you will. Right? She begins to ask a number of questions and guides her students into how to solve the problem. There's not much thinking that's going on by the students. There's not much work that's going on by the students at this point. She's doing that for them. And one of the things this does is it really takes away the opportunities for students to wrestle, struggle through this problem. And it also sends the message to students that if they struggle, the teacher is going to step in and do the work for them, because answers are what's most important, not struggle, not problem solving, trying to get the answer. In Miss R's class, on the other hand, when she again notices the same sort of struggle, instead of telling students what to do, she focuses their thinking for them, gives them options for sure about what they can do, and sends the message that if you're struggling, I, as teacher, am here to assist you, but it's your job as a student to struggle through this, to figure things out. One of the things I work with teachers all the time, and one of the things I often share with them is that learning isn't meant to be easy, and it's never intended to be fun. But anyone who's ever had to learn something really challenging, really hard, knows that learning is rewarding. Um, and that is something that you can't take away. You don't want to take away from your students. The value and the rewards that you have from spending all that time, that frustration, but finally getting through it, that aha moment, realizing how valuable it is. And so in this case, in Ms. R's classroom, thinking and struggle are what's valued most. So after creating that environment, now we got to give our students opportunities to engage in struggle, and develop that mindset that struggle is part of problem solving and that's okay. And then we also want to support them, not rescue them along the way. So, first thing, what do I mean when I say we got to give them opportunities to problem solve? Well, I'll sort of show you better than I can tell you at this point. So here are some examples and some non-examples about what I mean. And these come from all different math topics and a variety of different grade levels. So on the left here, we have a truck. We're given the dimensions of this truck. We're also given some boxes and the dimensions of the boxes. The challenge or the task is for you to figure out how to organize these boxes in the back of this truck so that you can fit the most number of boxes in the truck. That's an example. On the right, we have a storage unit, I guess. We're given the dimensions of the storage unit, and we're asked to find the volume. So I'll give you a few moments just to sort of flavor for these two different problems, both about volume, but very different in how we're using volume. So take a few moments. You're not going to have enough time to solve them, but I want to give you an opportunity to at least play with them a little bit. Okay, again, I know I realized I was probably not enough time, but hopefully you had a chance to play. I got some more problems for you, more examples. This time we're talking about ratios and proportions. Both of these are about ratios and proportions. On the left, the example, we have two students. We're given rates for how fast they run, and a couple of questions about who's going to win a race, and who's faster. And on the right, a few proportions were asked to find the unknown or solve for the variable. Give you another example. Both of these, believe it or not, are about the Pythagorean theorem. On the right, the non-example, we have some triangles, and we just need to find the length of the hypotenuse. On the left, here we're given an image of a sphere. It's an orange, and part of the orange has been cut off. And our job is to figure out the area the top of that. In order to get that, the hint is I'll tell you is that you need to use the Pythagorean theorem. But how to use it is very different. So again, I'll give you a few moments just to sort of play around, get a flavor. Probably not enough time to solve. A few more examples for you. Here we have a bucket of chicken wings. And there's a lot of chicken wings in this bucket. And based on the number of wings we remove at a time, there may be some remaining chicken wings left in the bucket. Job is to figure out the minimum number of buckets possible that go into the bucket, given what we know about the remainders based on how many we take out. So I'll give you a moment just to play with this one. Looking through the chat, I see lots of great discussions going on here. I apologize, things are moving so fast. I'm not able to manage all of that, but I do see someone has proposed 119 as the answer. So for those of you who are working on this task, I invite you to consider this hypothesis, and you can check for yourself what you think. One more example, by the way. So this is if you're exploring this task, we're talking about common multiples here. So this is I noticed earlier in the chat people talking about the variety of ranges of math ability. So this comes from an elementary standard, for what it's worth. Not to say that to take away from common multiples, but there's lots of tasks at all different levels that you can engage your students in. You don't have to wait until your students have some degree of sophistication under their belt before you can engage them in problem solving. Another task, here we have some screenshots of a laptop. You may recognize something like this, whether on a phone or a laptop, where we're charging it up. Question is, based on this data, how long is it going to take before we get to 100% battery life? And one more example for you. So here we have a square birthday cake. And if we have 7 people that we want to give the same amount of cake and frosting to, how should we cut this cake? So I realized that I didn't give anyone nearly enough time to answer all of these tasks. Again, I don't think um, uh, the idea here is for you to do the math, although I invite you to come back and work on these problems later. But really, where we're at is what do these problems look like? How would you describe these tasks? How do they compare to some of the non-examples? So take a few moments to think about, and if you're willing, share your ideas in the chat. How would you describe the example tasks? How would you describe the problem solving tasks that may invite struggle? I see real life. See, makes you think. Investigation. Smoke coming out of my brain. That's a good thing. Good. It means you're struggling, which is a great opportunity for learning. And here's how I would go about describing some of the differences. You're actually just describing the example tasks. And this I think is critically important. The first two, one, for it to something to genuinely be a problem, the answer can't be obvious, nor can the way to get the answer be obvious, right? Because if you already know the answer, then the problem is done, solved. You have no reason to do much work. And if you know how to get the answer, you're not problem solving, you're practicing. And practice is an important part of math too. In fact, practice is one of the best ways that we know to support procedural fluency. But a real problem, a real genuine problem is something, whether in math or something else, is something where you don't know what the answer is. It's not that obvious to you, nor is how to get the answer. That is a real and genuine problem. Now you got to figure out, well, what do I want to do? What's the best way to go about answering this thing? And it's probably going to require some thought. Maybe smoke is going to come out of your brain, maybe not, but it definitely is going to require you to do some thinking and put in some effort. It's not something that you can do mindlessly. It's not a procedure that you can just follow without really understanding much about what you're up to. It's definitely not something you can do multitasking, right? You're not going to be able to do this mindlessly. And ideally, these same sort of tasks can be represented in lots of different ways. So not a requirement. I think it really adds to um, problems when you can represent it by drawing a picture. You may be able to represent it on a graph. Maybe you can represent it using symbols or algebra. Some like hands-on manipulatives or maybe manipulatives online, especially in this sort of distance online environment that we're in. Um, for sure. No standard operating procedure. I see that in the chat for sure. Yeah, yeah, absolutely. So after we've identified some really good problem solving tasks, and one thing I didn't really include here, but for some of you who are well versed in DOK or depth of knowledge, that's another way to think about these tasks, high depth of knowledge. And some of you might even be familiar with cognitive demand. And if you are, we're talking about high levels of cognitive demand for sure with these sorts of tasks. The next thing, after we've identified these tasks, we've given them to our students and invited them to struggle. We want to make sure that we support them in that struggle, but we want to do so in a way that doesn't rescue them, that doesn't save them. We don't want to be like Miss F. We want to be more like Miss R. We want to value the struggle, but not just leave them be and let the struggle turn unproductive. So, um, a long time ago, a famous mathematician, George Polya, he wrote a book called How to Solve It. And in this book, he describes problem solving as a four-step process. So, the first thing you have to do when solving a problem is you need to understand what is the problem, what's the context, what sort of vocabulary, language, what sort of things are going on there. What is this problem asking me to do or answer? After understanding the problem, you want to come up with a plan. How am I going to answer this plan? And then afterwards, it's important to look back. Did I answer the question? Does my answer make sense? Did I learn anything from this process? Lots of ways to reflect on your answer and the experience and the process that you went through. This book was written in 1945, but if you look at the standard for mathematical practice today, you'll still see the same sort of ideas that are coming through. If you look at just the first math practice, make sense of problems and persevere in solving them, we see that students who are proficient in the standard explain to themselves the meaning of the problem. In other words, they're understanding it, just like step one in FOIA. They plan a solution pathway. There's step two. Then down below, we see mathematically proficient students check their answers. They check back. They look back on their work. So that'd be step four. What's missing here is perhaps step three, but I think that's sort of implied. If you carry out if you have a plan and then you're checking back your answer, I think it's implied that at some point in time you carried out that plan. Important to note, this is not linear. Oftentimes, problem solving is messy, and you can start with understanding the problem, come up with a plan, realize that you don't necessarily understand everything about the problem, and go back. Or maybe you understand the problem, you come up with a plan, you carry it out, but you made a mistake, and you have to go back somewhere and revise your plan. Or maybe you get all the way to the answer, you get an answer, and you realize the answer doesn't make sense. So now you got to backtrack to another point in the problem solving process to make sense of it. So thinking about problem solving in this way, wherever your students are, we want to make sure that we can support them in this process. So if you happen to find that your students are struggling to understand the problem, one of the perhaps most effective strategies that I've seen and come across is called read two ways. It's actually adapted from read three ways, but for time's sake, when working with students, and also I think just as efficient, is asking your students to read the problem in two ways. Now, this works really well if you have multiple students working on a problem because they get to bounce ideas around back and forth. But if you're just working one-on-one with the students, this is equally as effective. Maybe the discussions aren't as rich because you don't have different ideas, but nevertheless, the strategy is simply to first ask your students to read the problem and forget about the numbers. Just read it to try and understand the context. And you might even ask them in their own words to describe what's going on. Don't pay any attention to the numbers. Don't bring any values. Just understand what's the scenario here? What's the story? And after you get that, then you ask them to go back and read the exact same problem again, but this time, and with an eye towards the quantities in the problem, towards the numbers in the problem, and thinking about how they can represent this problem in a drawing. How could you draw this problem? How could you draw this scenario, including these values, including these numbers? For students. And this will help students make sense as a way to help students make sense of the problem. So for example, let's say that you have, you give one of your students or you've given your classroom of students the chicken wing problem. And as soon as you've asked your students to figure out how many wings are in the bucket, you have a student who raises their hand, maybe has a look of confusion on their face and says, you know what, I don't really know what's going on here. I don't know what this problem is asking me to do. So great. Now I know the student doesn't quite understand what the problem is, and you can employ the read two-way strategy. So you might ask the student to read this, and then in their own words, maybe even ask them to write it down if they can. A summary of what this problem is, and don't use any numbers in your summary. Just tell me about the context. And then after they've done that, you can go back, and this might take some unpacking. If this is an unfamiliar context to them, it might require you to help explain this context. If this is something, if students aren't familiar, for example, with chicken wings, they don't know what chicken wings are. They don't know, or they're not familiar with going and getting a big bucket of chicken wings. You might need to help explain some of that. And that's okay, because that's an unfamiliar context to them, and they're not going to understand it otherwise. And if students don't understand the context, trying to solve the problem really isn't going to do them much good. After they've understood the context, you want to ask them to go back, read this problem again, this time with an eye towards the values, the quantities, the numbers in the problem, and then think about how you might be able to create a picture, a visual representation, a figure, a drawing that includes the context, but also includes all the quantities. And this can be something like a comic, multiple steps. or multiple windows, multiple pictures based on the different sorts of scenarios. It can be done all at once. It's wide open, and students can take this any different way that they want to, as a way to try to better understand what the problem is asking them to do. And in thinking about and describing it in their own words and coming up with a model, they've done a lot of the heavy lifting for trying to make sense of the problem already. It might be that they've missed some certain things that we as teachers can point out. They might have missed a quantity, but we never want to focus their attention only on a few quantities. Because remember, problems are messy, and rarely do we come across problems in real life where we're only given the specific information that we need with no extraneous or no extra information. So that's a skill that students need to develop and work on. And it's really important not to just hone in on the things that we think are important. It's part of the struggle, it's part of the process, and they're going to learn by going through it. It might be that students understand the problem. Um, they're struggling in coming up with a plan, or they might have a plan, but they're struggling in carrying it out. So to support your students in these particular moments, you want to try using what Worcester calls affordance. It's the idea that you want to start by acknowledging the struggle, reminding students that this is a good place to be in. This is normal. They're somewhere in the pit, for example. And instead of asking a series of questions that may guide them to where you want them to go, just repeat or paraphrase back to the student what they're asking of you, and then remind them of all the various resources that they have to answer their very own question. That might be from a poster on the wall. It might be from you just verbally telling them there's lots of different things they can try. It might be from a handout you give your students with all the various problem-solving strategies. Nothing like cubes. When I'm referring to problem-solving strategies, we're referring to things like working backwards, like guess and check, like drawing a picture, like solving a simpler problem. So again, we'll go back to the bucket of chicken wings problem. Let's say that the student understands what's going on, but they don't know what to do. They're not quite sure how to come up with a plan. We don't want to give them a plan. We're not going to rescue them. But we might try some affordance, if you will. So we might notice, hey, the struggle is real, and it's really important for your brain. So keep going, because this is something that I'm not going to take away from you, and you're going to learn a lot more from doing this. And here's what you're being asked to do. So we're going to paraphrase next, trying to figure out what's going on, how many chicken wings there are, and then remind them of all the strategies. In this case, we have a nice, helpful poster that's on the wall that we can refer our students to. And again, you'd be surprised how the value that students find in something as simple as just a chart on the wall or handout that they have that reminds them of all the different resources they have available to them already. And a teacher can be on that list if need be, but they should have exhausted some of those other resources beforehand. So that's something of affordance, more or less. And importantly, if we're doing these things, great, but this is just the beginning. This is not the end of all of this process. We want to make sure that we have the environment. We want to make sure that we give our students these opportunities, and we're going to support them along the way. But all the problems we're asking our students to do are not just to be mean, not just to be cruel, not just for problem's sake, but because there's usually a mathematical point behind all of this. And so it's really important to make sure that, well, we make these moments teachable moments, if you will. I'd like to share some research with you very briefly that I think is really powerful in highlighting the importance of this. And it's called A Time for Telling. It's done a while ago, but it's so important that it's still used and talked about a lot today. What the researchers did is they looked at 3 different scenarios of students. In one scenario, students worked on lots of problem solving and reasoning tasks. There was never a lecture. There was never any instruction. They were just given these tasks and given many opportunities to problem solve on their own or in groups, and that was it. There was another scenario where different students were given lots of lecture, lots of instruction. So they spent lots of time in a classroom listening to teachers and opportunities to practice. So after they would sit for who knows how long and listen to the teacher show them what to do, then they would practice that a whole lot of times. Sometimes this is often referred to, at least in my world, as I do, we do, you do. Maybe you've heard of that. And then there's another scenario where students were first given reasoning and problem solving tasks to work on. And afterwards, there was a teacher who helped them unpack the work that they did through lecture, through explanation, depending on the size of the group. And one of the things that the research found, and this has been repeated in other research as well, is that the third scenario, the reasoning task with lecture students, significantly outperformed all the other students on lots of a variety of different achievement tests, not too different from the NAEP data that I shared with you earlier. Um, and one of the things they concluded is, first, once students worked on these sort of reasoning and problem solving tasks, their brains were ready. They were primed for new ideas, for more formal ideas to be presented to them, because they've been thinking they had that head in this space already. They've been working on it. And I quote from them here: "The question is not should we tell or explain, but when is the best time to do it. Clearly, the best time is after students have explored problems." So what does all this mean? Well, after you've given your students a problem to work on, they've worked on it, they've solved it, you might have supported them along the way with a read two ways, you might have supported them with affordance, they get an answer. That's not the end, that's only the beginning. You want to take the time to explain the math that's going on there, not the problem, the math. The problem might be an example, but you want to think bigger than that, because there's always a time to tell. And if possible, you want to make sure that you can connect the work that the student did to whatever you're trying to explain. So let's say that you're giving our students this problem that involves a laptop and we're charging it up. For what it's worth, this comes from an integrated math 1 standard. Also, depending on the type of questions you ask, could be in the level of middle school math, wherever your students are. The idea is they're going to draw a line of best fit using this data. This doesn't map out nicely to a nice straight line, but it's close. If you were to plot this information on a coordinate plane, that is. So this particular student notices that from 927 to 936, those are 2 data points in the screen captures, that it looks like it's almost increasing by 1% per minute. So if we follow that logic, we get to 10:17, we just got to go 9 more minutes because we're at 1% a minute, and that will tell us the time that the battery is charged. So that's what the student is coming up with. Great. Doesn't end there. Great problem solving. But really what we want our students to know is about lines of best fit. That's the math that we want our students to understand. So from here, let's check in with the student. Let me tell you about lines of best fit and what this sort of process looks like, how we want to go about doing this. And I just sort of simplified it by talking about this in terms of 3 steps, right? You would just graph the data. So the points that you see there come directly from the points that we see here, with time on our x-axis and percent on our y-axis. After we have plotted the data, we want to draw a line, make sure that we sort of balance the number of points above and below our line. And then third, we can extrapolate. We can take this line, extend it out as our part of our model, and use it to predict other points, like when we're going to reach 100%. And that is one way that we can think about lines of best fit. And after we talk about this process, about this math, not just the problem, but how lines of best fit shape into all of this, we want to connect it back. So one of the things this particular student did was they were thinking about slope, this rate of change from 2 particular data points, which is great. We can connect that back to part of what happened in step 2 with drawing that line. We can also talk about why that's just for a certain part of the line and why it might be limited in terms of scope and so forth, and help the student because they're primed, they're ready, they've been thinking about this, they've been spending a lot of time turning this idea on its head, trying to answer the problem. They're ready to learn about line of best fit, and they're ready to hear more. So I'd like to pause for a minute and ask all of you to think about how you can support students' struggle in learning math, and how might this reflect you stepping outside of your comfort zone. No need to share in the chat, but I want to just give you a few moments for your own reflection. So I know that there was not enough time. Definitely apologize for cutting short any reflection, which I really value and think is critically important for teaching, for learning, and hope that you spend some time and thoughts after all of this, noticing the time. I want to make sure that questions, comments, insights, at least get an opportunity to answer a few before our time is up. So I'm definitely monitoring the chat at the moment. So if you have any questions, please write them in, and we can talk.
So, Matt, there's been a lot of conversation in the chat and a lot of questions and a lot of people helping each other, which is great. One question from Michael Spear is about, and I'm going to try to paraphrase this, Michael, if this works for you. Um, how much how much math do you need to know in order to be successful at struggling with a problem? In other words, you don't want to give a student a problem that's they're not going to be able to solve no matter what they do. So how do you kind of gauge? Do you have any words of wisdom about how to gauge that, the level of difficulty?
Yeah, well, my first thought, not to get too much into the science or the research, is we're looking for the sweet spot, the Goldilocks spot. In my line of work, it's called the zone of proximal development, which is to say, it's that space where students are going to struggle. It's not too easy for them, and they might need some support, but they can do it, and someone doesn't have to take over the work or thinking for them. And that's not easy to find. And to be honest with you, even I, though am aware and mindful of this all the time, even I'm not perfect at it. I think it comes with just trying things out with your students, giving them opportunities, identifying the things that they work. And one of the things is your students, and I mean this sincerely, your students don't have to always arrive at a right answer. Um, in fact, if they come to a wrong answer, so this is one of the things we talked about last time, and maybe a small plug to go back and look at that. But even if they didn't, remember there's always a time to tell. And so one of the things you could do is after they're done, or maybe they get stuck even, and the struggle isn't productive, the struggle is very unproductive. There's tears, or maybe not tears, but you can clearly there's no longer a worthwhile it's no longer worthwhile to help your students work on the task. Move on to tell. And one of the things you can do is say, hey, listen, let's say that we're working on I'll go back a few slides if I can. Let's say that we were working on this task here, and the student is just completely frustrated and says, I don't know what to do here. One of the things you can do is you can go and say, hey, well, let me tell you about lines of best fit, and let me show you what step 1, step 2, and step 3 look like. And then put it back on the student and say, now that you've seen this, now that you know this procedure, how might you use this to answer this laptop problem? Or maybe you do that together. Maybe you explore it and say, so here's how step 1 might look like with this laptop problem, and work with them along the way on that end. So I would do that if I've recognized that perhaps maybe I've chosen a problem that's outside of their ZPD, or well outside of that Goldilocks era. That might be something to just be open with your student about and say, you know what, perhaps I chose a problem that isn't appropriate for right now, for right now, because I still do that all the time. But it's still a way to make it a teachable moment by helping your student. And one of the things I'll also add to that is, in acknowledging that you've made a mistake, that's also another really powerful way to show your students that mistakes are normal, that they happen all the time, and that they're okay. I was at a talk a few years ago. Carol Dweck, who is the one who introduced us to growth mindset, and one of the things she said is that's perhaps one of the most important things we as teachers can do to help our students with the growth mindset, is to make mistakes and not sweep them under the rug, but rather be open and honest about them and let them know that they've just happened, and that we all make them. And even teachers um, are going to make mistakes. So I don't know if that answers all of the question, but know that that is something you're struggling with. And I would say, great to that. You are now learning about it, and hopefully stepping outside of your comfort zone in doing so.
Well, thank you. Thank you so much. I don't know how you do this, Matt. You have so much information. You give us time to think about it, and somehow you wind up exactly right on the dot of 2
Yeah.
o'clock.
Well, I'm
So
also always mindful of people's time. But if you want to keep the conversation going, I always enjoy it. Here is my email address. I'm happy to keep the conversation going. Shoot me an email, ask me questions, and I will absolutely find a time to respond.
thank you. So you'll all see that there, Vicky has put a link in the chat for the evaluation of this event. You'll also receive it. You'll receive a follow-up email from us with the link there, and we really hope that you will fill out the evaluation so that we know whether to continue this thread, go somewhere else, do something different. So please give us your feedback. Thank you so much for being a fabulous audience and being so engaged and having so much to say right here in the chat. We really appreciate having you today. Hope you've learned something that you can take back and use. Thank you, Matt. It's always a pleasure. And everyone, please enjoy the rest of your day.
Yeah, thank you, everyone, and thank you, Marion.
Absolutely.